So this is the second half of the little lecture here on pop bottles and bulletproof vests. First half we talked about making a polyester, which we made by reacting a dielectrophile and a dinucleophile together, and it required a dielectrophile and dinucleophile because in the repeat unit we actually had two functional groups appearing. So if we have two functional groups in the repeat unit, then that means that you're going to have two different monomer molecules that are going to be together. If the repeat unit only had one functional group, then you would have a monomer that has a nucleophile on one end and an electrophile on the other end. So the second half of the lecture then will be on bulletproof vests, which are made from Kevlar. Kevlar is an extremely strong, very lightweight but strong polymer, and it is actually a polyamide. You can see one amide functional group clearly there, and if you can do the wraparound mentally, then you see this carbonyl is bonding to this NH and forming another amide on the other side of this aromatic ring. So again, we can draw out 2 or 3 units of the monomer connected to each other to get a better sense of what's going on overall. And if we start somewhere, here is an amide. So if we're breaking apart an amide, we would have a carboxylic acid or an acid chloride here and an amine over here to react to form that amide bond. Then if we went through the repeat unit, we go through a couple carbonyls, then we have an NH and another NH before we get back to the carbonyl. So here's the repeat unit that we are making, and you see that there's one amide at the end of the same amide at the end of both ends of the repeat unit, and then we have an amide forming in the middle there. So you can see then that this used to be your dielectrophile here, and this used to be the dinucleophile. So we can break that apart. And form it from a carboxylic acid chloride, which we typically use to make amides. And the amine, the diamine. So here's our dielectrophile, and here is our dinucleophile. Our dielectrophile came from terephthalic acid, and so if we're making the acid chloride from that, then we will drop the ic acid and add YL chloride. So this is terethalloyl chloride. And this diamine is a phenyl ring that's substituted in the 1 and the 4 positions with an amine, and this is known as 1,4-phenylene, which is what we call a phenyl group if it's in the middle of a chain, phenylene diamine. And we need no catalyst. An acid chloride reacts with an amine instantaneously, and we form this Kevlar polymer. If we were going to make a polymer that has one amide group in it, like this, then we have carbonyl 1, 2, 3 methylenes, and then another carbonyl. So if we were going to draw a fragment of that, 1, 2, 3 carbonyl NH, and then 1, 2, 3 carbonyl NH, then 1, 2, 3 carbonyl NH. We have our repeat unit there with 3 methylenes in between each NH and carbonyl. 1, 2, 3 there. Then if we were going to break that apart at the amide connection there, then we would have one monomer that has an amine at one end and an acid or acid chloride at the other end. And so if we, same ongoing problem, forgetting to shift up here. If we have the amine at one end and an acid chloride at the other end, this actually you can't do. Why can't you do it? Because you can't have two functional groups in the same molecule that could react with each other. This would be like having a carbonyl at one end of a molecule and a Grignard at the other. No such thing. So this won't work. Instead of doing that, we have to have a less reactive electrophile on the end, and so we can do that by reacting the carboxylic acid on one end. And remember what we said with carboxylic acid and amines, we have a competing reaction, which is the acid-base reaction. This is acidic enough to transfer, proton transfer to the base there, and so we have this competing reaction with it. So we've got a little bit of a problem here, and we will have to drive both of these are actually equilibrium reactions, and we would have to drive the equilibrium to favor the amide product. So you can react an acid and an amine together, but instantaneously the acid-base reaction happens, and in order to get the amide formation, we have to talk about the thermodynamics, which we will do in the next video.